Here we're going to look at question 71 from the IMAT 2012 paper. So in this question, we're told we have an iron block which is at 100 degrees C and it's dropped into some water which is at 20 degrees C. Then what the question asks us is which of these is not necessary to find the specific heat capacity of iron, alongside which it gives us 5 different choices or variables which could be involved in this reaction. So if you'd like to have a go at this question yourself, then please pause the video now, otherwise we'll have a go at it together. So in this question, we're being asked about specific heat capacity, and we're obviously seeing some temperature differences in here. So the first thing we should probably do is try and think of some equations which are relevant to this situation. And the one which probably comes to mind is this, that the energy in a reaction, or in a temperature change, is given by the mass of the object which is changing temperature, the specific heat capacity of that object, and the change in temperature. Given by this delta T here on the end. So what we could try and do is see how we can use this equation to look at this different situation. So we could use it for iron and see the energy change there. And then since we know that in this case we just have a closed system, all the energy is going to be conserved. The energy, which is in the iron block at a higher temperature, which is lost by this iron block, is just going to be transferred to this water. So we can compare the energy change for these two different materials. In doing that, we should try and find some sort of equation which relates the mass of the water, the specific heat capacities, and the temperature changes together. So let's begin by doing that. And first, let's do it for the water. So, to try and find the change in energy, then we're going to need the mass of the water. We're going to need to multiply it by the specific heat capacity of water, Cw here, and then the temperature change. So what I've done here is I've taken our final temperature X, and I've taken away the initial temperature, which is just 20 degrees C. Which I've done in Kelvin here, which is just because the units of specific heat capacity are generally done in Kelvin, but you could actually do it in degrees since we're just looking at a temperature change rather than an absolute temperature. But nonetheless, this is going to be our equation for the change in energy of the water. Now if we go ahead and do the same thing for the iron, then our delta E is actually going to be negative because our iron block is losing energy to the water. It's at a higher temperature, it's going to transfer energy to this water. So we're going to have negative multiplied by the mass of iron, the specific heat capacity of iron, its initial temperature, 273 Kelvin, take away its same final temperature X. So we know that the two things are going to reach the same temperature because you can imagine that if you were to leave some really hot iron and some water, they would eventually reach an equilibrium point at the same temperature. So these two equations are going to work for a different situation. And if we were to go ahead and equate these two equations, then we'd get this, since the energy changes are going to be the same. Oh, but just with a positive in here actually, that was just a little mistake I made, because this is going to be the magnitude of the energy change. So while up here the energy change is negative because iron is losing energy, in this case that lost energy is going to be equal to the energy change or the energy increase of the water. So this should be positive here. Now if we do look at this, then we can see which variables we have in this equation. So we have the specific heat capacity of iron, which is the thing that we're looking for, that we're told about in the question. And if we go through our other variables, we notice that we have the mass of iron, or the mass of water, which we're told about in the question. We have the specific heat capacity of water, which again we're told about in the question. We have this temperature X, which is the final temperature, given by D in the question. We have the mass of iron as well, which is given in the question. So we have these 4 variables on here, which I've labelled on, but we don't have this final variable C. So since this is the only unknown in this equation, if we would have the other 4, then we could find the specific heat capacity without thermal conductivity of iron. So this variable C is not going to be necessary, and therefore this final answer is just going to be C.